everyone. So this is week number 2, and this week we are covering functions. Last week, so we did patterns, right? And I told you about the linear pattern, the quadratic, the geometric sequence and series. And it's actually great that we're going into functions this week because they actually relate, all right? So this week we're covering linear functions, we're covering quadratic functions, or the parabola, however way you pronounce it. We're also doing the hyperbolic function, and lastly, the exponential function. So, we would like for everything to be linear in life and have a straight line, but not many practical applications are really there for straight line graphs. But I'll mention one, which you're going to cover in the financial mathematics series. So that's basically when you have simple interest, okay? Yeah, that's a linear trend that we see. Also in statistics, when we get to the last term, or yeah, the last week of these lessons, you'll get to see where you get to use linear trends to actually explain what's happening in whatever data collection that you have. And then next we look at the parabolic functions. Please don't mind the buffalo behind me there. So with the parabolic functions or quadratic functions, a practical explanation would be vertical projectile motion, which we're also covering this week in the physics section. So whenever you are kicking a ball or throwing a projectile, if you were to plot that projectile motion on your displacement versus time graph, you would see it has a parabolic shape. So that's a simple explanation or a simple example, practical example of a quadratic function. And then you have the hyperbolic function. So that one is not so easy to find practical explanation or practical example of. But if you were to remember in physics when you did lenses, okay, and you had that shape, remember you have either concave or convex, okay? So that one where if you shine light through it and you have a shape like this, it sort of has a hyperbolic shape, all right? And you would see when light gets refracted, okay? So that's one example of the hyperbolic function. And lastly, the exponential function, which I link it to the geometric sequence series. All right, so basically, like I explained last week or made an example, if we were to have a virus, you see it starts out very slowly and over time it just increases exponentially, all right? Even with like in finances, if you invest, especially if you have a good investment, compound interest, all right? So you would see you invest in something and continue giving off whatever on a monthly basis, whatever amount, and you see that over time it starts out growing slowly, but with that time factor, you'd see that ultimately your return on investment, your money starts increasing exponentially. So that's just, yeah, one of the examples that I can think at the top of my head. So I hope you enjoy this week's lesson. A lot of people say functions are difficult, especially when they put all the functions together. You have your parabola, you have your straight line, and then you have an exponential function, and you like get confused. Please don't get confused. Don't attempt or don't get into this lesson being afraid. Come being hopeful. You will learn and see these functions are actually quite nice, and it's great to know them because somewhere in life you are going to apply them. All right, cool.